Okay, for example 8, same scenario. We got 2x and 3x lined up in this column, 5y and 4y lined up in that column, 9 and 2 lined up in that column. X's, y's equal numbers. Everything's set up best for elimination here. Coefficients aren't 1, so substitution would be challenging if we tried. Going back to the decision, what do I want to get rid of, x or y? So the last one, I just gave Kevin free rein to pick. He picked x, and it's fine. There's no problem in picking x. For me personally, though, I make decisions based on what I'm looking at. The pro for picking x in this one is 2 and 3 are smaller numbers than 5 and 4. The pro for picking y is the signs are already opposite, so I don't have to multiply by any negatives. For me personally, multiplying by negatives tends to cause more issues than a little bit larger numbers. I mean, 2, 3, 4, and 5 are all around the same. If this said 2 and 3 and this said 57 and 49, yeah, I'm going to go with the 2 and the 3, right? But since these are pretty similar in size, these are already opposite numbers. If it were me, I would probably get rid of y in this case. Again, since the opposite signs already exist, when I'm multiplying by a positive. So if I take the top equation, I'm looking at 5 and 4, I'm going to make them both into the number 20. 5 times 4 is 20, 4 times 5 is 20. Always through multiplication, you're going to keep the number the same or bigger. You never go smaller on these. So I'm going to do times 4 to make negative 21 on the top equation. I'm going to do times 5 to make positive 21 on the bottom equation. And again, since the signs are already opposites, I'm multiplying by positive numbers. So again, that's just one little hint to maybe create less error. All right, so you don't want to mess up. Again, I'm concerned about y, but everything else has to change if I change anything. So if I'm doing 4 times negative 5y, I have to do 4 times all pieces. So 4 times 2x makes 8x, both positive, so it's positive. Positive 4, negative 5y makes negative 20y. Positive 4 and positive 9 makes positive 36. On the bottom, I have to do 5 times 4y to get the 20y I want, but everything has to multiply by 5 because of that. So positive 5 and positive 3x is positive 15x. Positive 5, positive 4y makes positive 20y. Positive 5 and positive 2 makes positive 10. Again, after doing that product, changing both equations in this case, just glance at the y's, make sure the opposites are there. If they are, you're good to go. If not, you didn't do it right. So once I see positive negative 20y in the y column, I'm good to go. I just add up the x's. 8x and 15x both positive makes positive 23x. Negative and positive 20y cancels. 36 and 10 makes positive 46. If 23x equals 46, we divide by 23, divide by 23. X ends up equaling 2. Okay. That's half of the answer. The other half of the answer, again, if it were me on my homework paper at this point, I'm going to go substitution. But again, let's just pretend I'm in that other boat where I got an unpleasant answer. How in the world am I supposed to find y if I get an unpleasant answer for x? So if I go back to my original problem, 2x minus 5y equals 9, and 3x plus 4y equals 2. I got rid of y, I found x. If I get rid of x, I'm going to find y. So if I go back to my original problem, just do another elimination. I'm looking at 2 and 3, I need them to be the same but opposite. The number I can make them become is 6, right? 3 times 2 is 6, 2 times 3 is 6. So I need to multiply one of them by a negative 3. Let's go negative 3 here to make negative 6x. Then we're going to take the other one times a positive 2 to make positive 6x. Again, since the signs aren't opposite, one of those has to be negative. It doesn't matter which one. I just chose to make the top one negative. So when I multiply, negative 3 times 2x makes negative 6x, what I wanted. Negative 3 and negative 5y makes positive 15y. Negative 3 and positive 9 makes negative 27. Doubling everything on the bottom, 2 times 3x makes positive 6x, both positive makes a positive. Positive 2, positive 4y makes positive 8y. Positive 2 and positive 2 makes positive 4. Okay. Once again, I wanted x's to be opposites. I verify that happened with my products. I can see negative and positive 6x are different, opposite numbers, so I'm good to go. So when I add the equations together, negative and positive 6x cancel. 15y plus 8y makes 23y, what I wanted. Y is still around. Negative 27 minus 4 is, or sorry, negative 27 plus 4 is negative 23. I subtract because the signs are different. It's negative because 27 is bigger. 23y equals negative 23. We divide both sides by 23. 23 divided by 23 is 1, 1 negative makes it negative. So negative 1, my correct answer is x equals 2, y equals negative 1. So again, with elimination, you're allowed to eliminate x to find y, y to find x. You get both answers. Or if you get an answer like this, you're allowed to substitute to find the other answer once you found that. So again, take your pick on that. I think most of the problems in the homework are going to be the type where you get these integer answers. There might be one or two where you get fraction answers. So if you get a fraction for this, I'd probably go elimination for the other one to find the other answer. It's probably easier. So whatever's easiest for you is what you should do. Pick the right technique for you and then solve to get the right answer. Every answer should look like this, except for the ones where both variables disappear, which we'll handle tomorrow. The weird ones, we'll do those tomorrow.